Afternoon, everyone. My name is Sanford Busse, and I'm a senior dashboard consultant with eTabs North America. Today, we'll be going through a basic introduction to data visualizations, starting with your basic charts, going on to special types, which ones are most effective, and then going to an exercise of definite right versus wrong situations. So moving right along, we have your basics. Everyone's familiar with the standard array of presentation charts. These are your basic visualization types that make up the majority of standard data reports. Chart types can have very general and very specialized applications. Probably the most widely used and the chart type most familiar to people is the column or bar chart. In vertical orientation, it's a column chart. Horizontal is a bar chart. Each set of columns or bars is typically a series, and the x-axis is categorical, sometimes showing a time series. A variation on the column chart, which adds a secondary y-axis, is the Pareto chart. This is just a single column series, usually sorted and paired with a second matched series, which is typically a line chart. Most often the two y-axes have different scales, so it can be difficult to interpret for those unfamiliar with it. A variation on the standard bar chart is showing it on a flipped or reversed axis, as I previously mentioned. Like a column chart, this is usually showing just a single sorted data series. A variation on the Pareto chart is a combination area and line chart. The area chart usually shows the primary data, while the line chart is used to provide context or a competitive benchmark of some sort. There are dozens of different data visualizations which are less common and usually associated with specific DataViz or design requirements. Radial gauges. Visualizations focus on a single metric, sometimes in combination with a benchmark or other context indicator. Gauges can provide an enhanced visual experience by mimicking their real-life counterparts, such as the gauges you find on an automotive dashboard. Linear gauges are a linear graph type which, like a radial gauge, can effectively mimic its real-world equivalent. For example, a thermometer. The bullet graph is another subtype of linear graph, but can be used to display quite complex data in a very compact space. Using background colors or shading in context or benchmark indicators, bullet graphs can convey a great deal of information at a glance and in a compact design footprint. An example at the top, the black horizontal line is the key measure, or KPI. The numeric scale is a standard quantitative scale. The graduated shading behind the line here indicates to show the relative performance of that key measure. Yet another indicator, the marker perpendicular to the key measure, shows the expected performance benchmark. Other types state indicators, which are typically used in conjunction with standard DataViz chart types to provide additional context, such as positive and negative performance. Geographic maps are effective for displaying location-specific data in a context familiar to most people at first glance. It could use like at the bottom left, or as in the example on the top right, a more complex integration of colors and a bubble chart. Basic labels can always be used as an efficient means of simple conveyance. These are used when there is no context necessary. Radar or spider charts are a great alternative to a cluttered column chart when working with a more complex multivariate data. Many types of special charts have specific DataViz applications. Scatter charts are useful for advanced research analytics like correlation and correspondence mapping. Stock charts can show 4 different data series per single chart element, such as this example where we show stock price open, high point, low point, and price close. Radial style charts are useful for presenting long data sets that might otherwise be overwhelming in a more conventional chart format. So which visualization is more effective? Beauty is in the eye of the beholder. And that's true in the data visualization realm as anywhere else. Next, we'll look at DataViz type comparisons to determine which may be more effective in communicating the designer's intent. Some can go either way. In this example, the line chart isn't the best match for this data, as the x-axis is categorical, and there doesn't appear to be a trend to speak of. This example could really go either way. Depending on the context in which the data is to be used, if the data is showing a share of the overall whole of sales, then the pie chart on the left is probably the better choice. If it's simply showing sales figures as standalone components, then the column chart is probably the better option. Rather than a question of being appropriate for the data, the next few examples are more design considerations than anything else, really. Here, both charts effectively convey their data message. The question is whether you want to be more stripped down or show more context. If the visible y-axis scale and grid lines help the viewer to better understand their data, then those are definitely useful elements and should be included. If they don't, then they can be left out. This is referred to as removing non-data pixels. In other words, any design element that isn't obviously needed can be considered extraneous. This is along the same lines as the less is usually more theme. Here, if the different subcategories of clothing have unique colors, which would match specific themes throughout your presentation or overall visualization experience, then we would want to keep these different colors. If this is a standalone chart, though, maybe having a single color to unify them under the single clothing category would be a better choice. This shows the importance of the use of color. The yellow is obviously a little more harsh on the eye, whereas the chart on the left has a softer tone and might be more palatable to your user or your audience and aiding them to consume the data more efficiently. This is another example of non-data pixel usage. While 3D charts might be seen as flashy and impressive, they can also have a negative connotation to them where they don't contribute much to the actual message behind the data being shown. Labeling on charts should always be as clear and concise as possible. The goal should be to take as much effort off of your audience as possible. So obviously the chart on the right is making the audience or the user work a little harder here to see what labels actually are. Here's an example again in the labeling of a chart. Removing the zeros and adding good descriptive labeling makes things easier for your audience to digest. Here's an interesting example of subtly adding subjectivity to otherwise straightforward data. Choice A is typically how column or bar charts look. The y-axis scale minimum is set to a 0 value. The relative differences between the subcategories are somewhat minimized. Choice B, the y-axis minimum is dynamically converted. So you can see it starts at 500 rather than 0 to kind of accentuate those differences. If this is the overall intent and the message behind the data, that's great. Otherwise, it's usually best to adhere to a more universal design practice. So now we move into exactly what can be considered. There's no gray area. These are definite right and wrong examples. The top chart is a typical application of a line chart. The data is trended over time along a continuum on the x-axis, and the line chart is entirely appropriate. The bottom chart is less so, as the x-axis is categorical, and showing a trend really doesn't make sense in this case. Here we have the same data as the previous example, but displayed in area charts this time. The top chart correctly shows the data as a stacked area. The bottom chart shows it as two individual area series. In this case, they overlap, and we actually lose some of the data behind. The pie chart on top shows 4 data points in this series, displayed as a share of the whole. The bottom chart, however, has too many data points to be effective. Again, you're forcing your audience to work too hard to view the data behind the message here. You should really consider using a different chart type with these multiple data points. Here's an example of why 3D visuals should really be avoided entirely. Chart sections are skewed and no longer relative. You can see the shoes category of 8 in the 3D visual looks much smaller than it actually is in the share. So thank you for attending. I hope you found